This week, this week in firewalls. That's what we're doing. So, if you have seen or you will see soon Cisco ACLs, that will help you understand this topic. If you have not seen Cisco ACLs, well, bear with, we're in for a bumpy ride. But this stuff is really not that complex if you can kind of visualize how these network rules are going to be, I guess, acted upon. So let's just dive into it and you'll see what I'm talking about with this. So, IP tables. I would rather not really just, dive whole hog into IP tables. There are, I won't say better tools, but there are way, way easier tools to use. And we'll talk about them a little bit. I've got some stuff about them in OpenSUSE and in CentOS. You have Firewall D, and in Ubuntu, you have UFW, which is uncomplicated firewall. Both of those have GUI counterparts. So they have graphical counterparts where you are able to just pop open the thing and type in, oh, here's my profile, or not type in, click on, here's my profile. I want to stop all SSH traffic. Like you can literally click on the actually, you know what? I'll just show you what that looks like. I don't know why I won't do that. Assuming I have internet, that is. Apt install GUFW. So graphical, uncomplicated firewall, and in CentOS firewall, firewall dash config, firewall D dash config. I think that's what it is. So you have the command line in CMD, but then if you do config, then that will bring up the GUI. So it's very similar to this. Let's just look at it real quick. I like GUFW mostly because you can explain it to just about anybody. GUFW is very, uncomplicated. It really is. It really absolutely is. So let's look at firewalls for a minute and just kind of figure out what's going on. So UFW has the same idea that that Windows has dealing with its firewall, right? You have this public option that will quite literally just say, reject everything from everybody. I don't want to hear from anybody at all. I just want to allow stuff out, and then whatever. If it originated, and we're going to talk about this idea pretty in depth, but if you think about that, right? So a firewall is meant to just stop traffic, right? And in a public type scenario like this, you are saying that I do not want any traffic to be accepted from the outside world into this machine, so in my case it'd be this VM, right? Well, that doesn't actually factor, right? Because if you're not accepting any external traffic, then that means that if I went out to a website, then all of the traffic that the website sent back to me would not ever be received, right? Well, it turns out there are, I guess, there's a solution for that. And it looks pretty complicated in IP tables. This is what it looks like, actually, doing exactly what I was saying. That is what an IP tables rule that says, I don't want to receive any traffic except for traffic that I created. So if I went to Instagram.com and requested Instagram to send me stuff, then yes, let that through. Otherwise, if it was not originated from me, then block it. That's what that rule says. We'll go back into that rule and kind of break down what all that junk means, but that's the idea. That's what this public setting is doing. Block everything but stuff that I requested. And then you have home, which will kind of do the same thing. It's a little more relaxed as far as, no, it's off by default, actually. It's a lot more relaxed as far as all the rules go. So if you come down into rules, there's really nothing. So this is basically saying that you can usually just say allow to everything. But at this point, why do you even have a firewall on, right? I mean, if you're allowing everything in. But it's a little easier to kind of configure this if you're working with essentially a blacklist instead of a a whitelist. It's a lot easier. You spend less time having to configure it if you do it this way. But then again, it's not necessarily the safest, right? Easy is not always safe. So what you can end up doing is something like this, right? So allow inbound. So to me, you can choose, your categories, your subcategories, basically. But then applications a lot of time are going to be the easiest way to deal with this. But all it really does is deal with ports. This application just deals with a port. So, and these are all different games that you might want. Well, actually, it's everything. So let me see. You can probably do SSH, right? Yeah, there it is. Application, SSH, and you can just allow in all of that stuff, right? So if we look at that, there you go. So here's what we can do. We can deny everything except for SSH, right? We are allowing SSH to anybody, seems like, to access our machine over SSH. And you can go in and edit this rule even more and say, okay, you're right. I don't necessarily want it from anybody. I want to be able to just accept it on one interface. So think from a server point of view, you might have more than one interface with more than one IP address. You can say, I only want to accept it on this one interface, which you can think about that as in the interface that you're accepting it on is a administrative VLAN that only IT staff have access to, right? That's a much safer way to deal with that. Or you can add, an IP address, right? Like I only ever want to accept SSH connections from one single IP address. But the overall idea is that this is how a firewall works. I think you guys have seen this in Windows, so it's not too terribly foreign to you. So that's the deal. And that's what UFW will look like. So now we can get into this IP tables idea. So like I said, IP tables is pretty much that exact idea, except it's on the command line, and it is crazy in depth. We're only going to scratch the surface of this. That's all you really need to know for a test like this. So don't. If you want, you can delve further in. But at least for this class, you don't have to go any further than what I've got here. So anyway, there's some concepts that you want to know about in IP tables, and that is the way that traffic will be dealt with. And that's this, right? You can accept a packet, so this is the same as allow. You can drop a packet, this is the same as block, and reject a packet. That is blocking, but nicely. So when you block something, you basically send back a message that says, hey, I blocked this, so And the action of what happens to that packet is the same between these two. Reject just goes one step further and says, hey, nuh-uh. So, you can use either of these. And on the internet, it's nice to reject packets, but then again, you may or may not want to do that. And, there's no rule saying that you have to. Reject is just a nice way to do it. So if you're trying to be nice on the internet, well, then obviously, okay, cool. You can do that. But you are not obligated in any way to reject things rather than drop things unless you want to be informative about what you're doing. And in some cases, you don't want to be informative about that, right? If you're rejecting pings, then you probably don't want people to know that you're alive, right? Your device is even responding at all on the internet. So reject would probably not be the best way to do that. You probably just want to drop that stuff. But like I said, if you want to be informative, reject, not drop. All right, so the last thing is log. So you are able to not do anything with a packet except just log the fact that it exists or that it happened. That's pretty much it. So you'll usually find a log right next to another rule, or right before another rule that says the exact same thing that also does one of these things. That's pretty much it. You don't usually find logs. No, you do. But a lot of times you will find a rule after the log deciding what to do on a packet. All right. So those are the 4 actions that you can take on a particular thing or on a particular packet. So here's the deal. There are lists. And you can see, oh yeah, because we have UFW, there are tons of rules already. But here's the thing with UFW and Firewall D and the old OpenSUSE Firewall 2 thing that may come up in your OpenSUSE career. UFW, Firewall D, and the OpenSUSE one all are really just front ends for IP tables. IP tables underneath all of it is really what drives firewalling. So you are not, if you're doing UFW, you're not doing something totally different that doesn't compare or that doesn't translate to other things. It's just a way to configure IP tables without having to, see stars looking at commands like that down there. So, and Firewall D is the exact same way. So when you list, if you have one of these tools, UFW or Firewall D, you will probably see rules. And a lot of these rules really just are describing what I was describing earlier, right? You can send information out, but you will not receive information in unless you specifically requested it, stuff like that. So anyway, so the different types of lists. Here's where it starts to get a little heady. So pre-routing. Pre-routing is a list that you will modify if you do not want the kernel even thinking about processing a packet. So you can kind of think of pre-routing as blanket denies, right? Like if I want to block any kind of traffic from an entire subnet, I'm going to block, stuff that you would normally block, right? Like the private IP addressing sets, right? Like 10.0.0.0/8. I want to block all that, right? I don't even want the kernel to think about that. Then you would stick that in pre-routing. Now, you don't necessarily actually go in and say pre-routing all the time. Most of the time, you're actually just saying input. But if you're doing blanket denies, stuff like that, where you know for a fact that no matter what protocol, no matter what IP address, no matter whatever, I just want all these packets to be denied, you can stick all of the rules in pre-routing. But as I said, most of the rules that we're going to be dealing with are going to be in input or output. Forward. This is only for if Linux is acting as a router. So one of the cool things about Linux is that it can be used for a gajillion different things, right? Any device out there that already exists can probably be recreated in Linux in some form or fashion. And yep, those fancy $5,000 Cisco routers, if you have the right equipment hooked up to your machine, can be turned into an equivalent. Linux can be turned into an equivalent router. So that is something that you can do. So you have IP tables does take that into account. This is why IP tables can get so complex. So you have this forwarding list that can be used for situations like that. You receive a packet, you process the packet, and then you forward the packet. So when you forward that packet, these are the rules that you're configuring at this point to pass those along. How do you want to pass those along? Here's the rule that I'm using to forward this on. So think about it like, you receive a packet and you forward it on, but you only ever want to forward it onto one network and that's it, right? Just so that you can log things or things like that, right? So there's a ton of scenarios where you could use this, but again, you're typically only using it when Linux is acting as a router of some sort. Now, input. This is the big one. This is the one that you need to pay attention to, and this is a really good time for Rhonda to hop in. So, input. This is pretty much where all of your rules are going to go. All the rules that I'm going to have you guys do today are going to be either in input or output. So the input list, this is your typical firewall. This is what you would be expecting as far as what you can do by to drop packets for some specific reason, or to reject specific protocols or something like that. This is where you're going to do that. So, and this is where these rules really come in, or where I want you to really pay attention to them. So, on input, so saying Linux has decided that, or the kernel has decided that it's going to take this packet in and do something with it. So now we're in this input list, and we got to decide what we want to do with it. So we can drop it, we can reject it, or we can accept it. Or we can log it, of course, but we probably want one of these three. So if you don't hit something in pre-routing, then you're going to deal with this. Now, you can do something. The example that I have in here is accept only packets from that IP address destined to port 22. Or you can, here's kind of the opposite of that. Drop packets from that host if it's coming to port 80. So it's just a way to block individuals, or you can block networks. We'll look at examples of how to do that. And then output is the same exact thing, right? Except for you're going the other direction. So I'm not trying to block or accept packets that are coming to me. I'm trying to block or accept packets that are going out of me. So think of, you can do this with you can block Facebook like this, right? You have to gather up all of Facebook's IP addresses in the U.S., hope that someone doesn't have a VPN, and you can just block all those IP addresses. So while you might be able to resolve Facebook.com, NS lookups will work, you will not be able to actually go there. So you can say block or drop packets. I guess you would say, instead of from, you would say to Facebook's IP on port 80 and 443. So that's basically just the opposite of input. Post routing is a lot like output, but you can also apply this to packets that are being forwarded. So after you have dealt with them and you know what you're going to do with them, you can add a little bit of salsa at the end with post routing. But again, like I said, input output are really the ones that we're going to be dealing with in our scenario. So don't worry too much about the other ones. Know they exist and know what they are for, but we don't really have to worry about those lists. All right. So when you throw out a IP tables L, capital L, that's really what you're seeing, right? You're seeing the input, you're seeing forward, right? And you're seeing output. And you're also seeing the default policy. So the default policy right now is to just accept everything. So on the way in, input, right? Accept. If we were to be routing and forwarding packets, yep, everything, cool. And output. Any kind of traffic can go anywhere at any time. And then we start coming down and looking at these particular rules. So this is how you read this thing. Chain is the same as list. The reason they call it a chain, and you're going to run into this in Cisco, you're going to run into this with pfSense. When I throw that at you guys in your internet class, every firewall tends to work. We're talking like 95% here. There are firewalls that don't work like this, but most firewalls that you encounter are going to work from the top to the bottom. They are going to take this packet, they're going to receive a packet, and they're going to say, all right, this packet matches what rule? And they're going to start from the top, and they're going to go to number 1. And it's like, all right, what does it match this rule? No. All right, number 2, number 3, number 4. And let's say there are 10 rules in that list, and we make a match on this packet on number 6. Well, we're done. We don't go to number 7. Once the packet matches one of those rules, it applies that action to that packet, and it's done. It doesn't go to 7, doesn't go to 8, doesn't go to 9, doesn't go to 10. Right? So, like if you look at this, input. If this third rule is what my packet matches, I don't deal with any of the stuff outside of this. So, Logging is an exception to this because logging doesn't actually is not necessarily a routed action. It is just a put it in the log. So you'll find that in syslog or the kernel log, one of the two. Anyhow. Oh, and by the way, yeah, forward output, all accept. So if you want to see what I just saw, it's that or that. Right? Either will work. If you do an IP tables -- help, that's a really important command. You'll see that you can do either, and it'll do the same thing. It will list the rules in a chain or all chains. So you can say, like this, L input just to see input. So -L input, and you just see input, or output, and you just see output. So that's pretty useful when you just want to focus on looking at some specific things. But yeah, it's mostly up to you. There's a lot of gibberish that comes out if you don't do this stuff. As you saw. And actually, you guys won't see anything in the firewall. The reason I have all this stuff here is because I have GUFW and I flipped it on and off. So all of these rules got added in after the fact. So you guys, when you're dealing with Ubuntu, probably will not see any rules in here at all when you're doing the IP tables L. So be aware of that. Only if you install GUFW and start tinkering around with it will you see anything in here. But if you do see stuff in there and it's not rejecting a bunch of stuff, then it's nothing to worry about. All right. So that's how you can kind of get a little more granular when you're looking at the rules. And this is how you're going to be looking at the rules that you create. So if you've just added 3 firewall rules to the input chain or the input list, then this is how you're going to go look at them to check to make sure. And then you can read them from left to right, right? So let's see here. Oh, yeah. So we're already deleting, but we haven't created any rules. So this should probably go down toward the bottom. I'll fix that later. So anyway, so we can start looking at how to kill packets now or accept, right? I mean, if you just this entire thing, if you change drop to accept, you flip it 180, right? Instead of dropping it, it accepts it. So all of these rules are the same exact language, and you just say, all right, kernel, do this to it instead. So let's look at this from left to right to try to English this out. So IP tables, obviously, Mr. Firewall. Which list are we talking about? So here comes the list and input. And then S for source. That guy. So basically what I'm saying is packets coming to me from this IP address will be dropped. That's how that reads. And no matter how complex it gets, you are able to do this with these lines. So let's put that in. So sudo IP tables. Oh, that'll break. IP tables. Input S 192.168.30.201 J drop. Okay. IP tables L input. Oops. And then you can see here. And then you look at target. What is it that you want to do? Protocols. Which protocols are we dealing with? Any extra options? Where is it coming from? And where's it going to? So I didn't specify me or anything. And you can. I think that's little I maybe. I forget. Yeah, little I, and you can say to my interface. So you can do that if you want. But yeah, or you can put your own IP address in there as well. That will work just fine. And I think that's the D option. So most of these options I learned forever ago, so I might be a little rusty on it. But yeah, D. D for destination, S for source. So if we swap that to output and that to D and rewrite that whole command, so IP tables A output D that IP address J drop, that would mean that they could communicate to me, but I wouldn't be able to communicate with them. I'm blocking packets on the outbound. I'm blocking packets to that IP address. So basically, I'm forbidding my server from talking to that IP address. So you can tinker with these a lot to get greatly different results. So you have to, though, spend a little time trying to English this out. That is the biggest thing, is figuring out how to read this stuff. And the only way to do that is to practice with it. So if you want to block an entire network, same basic thing. You're just adding in a little bit of extra notation. So you're putting the network ID /CIDR notation, and that'll work as well. If we, oh, I forgot to put the thing. That's why. There you go. So now this rule has actually become redundant now. I could remove that rule. And so removing that rule, let's see, right here, capital D, input, and then the number of the rule. We're about to find out if I remember that these rules start at 1 and not 0. We're about to see. So 1, 2, 3, 4, 5, 6, 7. I want to delete rule number 7. Sudo IP tables delete on the input list number 7. Let's see if I did that right. Yeah, I did it right. Yeah, it does start at 1. Cool. So to delete a rule, big D, the list you want to delete it from, and the number in the order. That's how you'll get rid of them. So now let's just say I've made a huge mistake. Things are totally broken. I don't know what's going on, and I don't know why. You can do that. And now you have no rules. F is flush. So if you need to get rid of everything because you've broken it in way more ways than you care to count, you can do that. And that will get rid of all of the input rules. If you just do that, that'll get rid of, oops, no, big F. That will get rid of all of the rules. Ah, man. Doing caps in this is so hard. Trying to keep it on track. So those are not the normal chains. So look here, though. Input, forward, output are all empty now. So UFW has created some additional chains that will do stuff, right? Like you can act on a packet after the input chain. So that's just UFW stuff. But those utilities are really cool because they make stuff so easy to deal with. Anyway, so let's say that you wanted to. Oh, we already did it. Yep. All good. Down here, yeah. So here's an example of how to block all pinging. Let's just say you don't care. I don't care who it's from, whatever. I just do not want pings to happen at all. So if they're pinging, coming to me, right? Coming to me because it's on the input chain, the protocol I care about is ICMP, and this is what I want you to do about it. You can swap that to reject, and anybody that tries to ping you say, no, sir, not happening. Now, this P, you can actually figure out what protocols you have by looking at this. So Etsy Protocols contains a list of all of the protocols that you would like to deal with, by name, that is. So RDP, that's actually not the right RDP, is it? No, that's the Reliable Datagram Protocol, not the Windows RDP. Huh. Anyway, and then you can add to this list if you really want. All right. So this is the same rule as, oh, wait, no, I thought I was talking about SSH. So this is how you block SSH. You can actually just type in SSH here. But as an example, this is how you can use a port number. So, I mean, nothing special. Just add the port number. Easy peasy. If you want to do a port range, so you can say IP tables on the input chain. I'm talking about TCP protocols, right? So this would block HTTP as well as 81, 82, 83, 84, 85. Let me show you what that looks like when you list it. It looks a little bit different when you list it than when you're putting it together. D port 80 to 100 J. Oops. Oh, yeah, that's why. TCP. There we go. L, input table. Oh wow, man, I've lost my head today. Sudo IP tables L input. There we go. So drop TCP packets from anywhere, destined to anywhere on the TCP protocol, starting with HTTP. So destination ports is what that stands for. Starting at HTTP 80, going to 100. So I am rejecting all packets on those 20 ports. And if you want to throw a network card in there, as I was mentioning before, you can use the -I option. So let's look let me see. I think that's my interface. Yeah. So sudo IP tables, A input, I enp0 S3, S, what have I got? It doesn't really matter, does it? J drop. Oh, wow. IP tables. One of these days, man. Yeah, so that's it. Oh, yeah, that's right. You got to do verbose. And I even have that on the next thing. But I was like, hey, where's the interface? If you do verbose, you'll actually see the interface. So this V basically says, give me more information than what you're giving me. I need more. Tell me more. Tell me more. And it will let you know this interface is what we're dealing with here. Only when it comes into this interface, right? That's what we're dealing with. Otherwise, by default, it's any interface. And you're going to hear the phrase any when you start getting into Cisco ACLs, and this is exactly what it is, right? Interface as in any. Yeah, so be aware, that's coming. Looking at IP address. Oh yeah. So if instead of dealing with an interface, if you want to specify an IP address to block from, so this source, and say maybe you've got an interface with multiple IP addresses, something like that, then you can just say, all right, well, I don't mind it coming to any other interface. I just don't want it on this particular IP address. So you'll do that with the D, the destination options. Now, so we were talking about a little while ago, sudo IP tables L. We'll look at that one more time. Look at this, and it says policy accept. So the default policy, unless otherwise stated, is to just let it through, right? And this is contrary. So I was mentioning how firewalls all tend to behave the same. IP tables by default does not care about traffic. You have not told it to care about traffic. So it's just going to let everything through. But most other firewalls work off the assumption of an implicit deny. And basically what that means is that unless you tell me otherwise, I'm just going to deny all the traffic. And this is a safety thing, right? This is making sure that traffic that you have not explicitly said is cool is not. I'll just drop it all. So you got to come in and say, all right, okay, well, I want traffic from this IP address, all traffic from this IP address. I want to open up SSH for everybody on any IP address or something like that. You got to go in and actually specifically say that. At the beginning, this can be really cumbersome. You can have a really hard time getting all that firewall set up because of all the implications that you're dealing with and all of the thought process that has to go into, well, what protocols do we need? What IP addresses do we need them from? Going through all of that. So setting it up can be a bit cumbersome unless you already have it figured out. So instead, IP tables, at least by default, has the policy of accept. If you want to make Linux behave more like your typical routers, it only takes one command. IP tables policy, the default policy on input is to drop instead of to accept. Now, you got to be careful with this. As I said, if you make this change, you pretty much lose all traffic unless you have other rules saying, yeah, cool, do that. Yeah, cool, do that. Otherwise, you'll be in a world of hurt. You'll have to write a lot of IP tables rules to make that work, or just go into UFW and add a bunch of rules to allow things. So let me see. Yeah, same deal. Now stateful rules. Here's the last little bit that I really want you guys to pay attention to. We've looked at a lot of rules so far, and I imagine you guys can cobble together a rule or two if you had to. There's one last thing that I need you to know, and that is this state. So the first thing is im. So im is basically I want IP tables to look at very specific things, and there's a list of those things, and that is state. So let me see. IP table. See if we can find im real quick. Yeah, match. Match on this thing. And if you go into the man page of IP tables, you'll find a list of the things that it can match on. And so notice I have an im up here too. So this is about as complex as it's ever going to get, at least in my class. And I think I only have one question that's asking you to do something like this. So it's not a huge focus. But you need to know that when you see this, that it's going to be important. Or at least you'll know how to figure out what the heck is going on here. All right, so let's read this from left to right and see what this actually does. So IP tables, obviously firewall. Inbound, on the protocol of TCP, on multiple ports. So I used destination port earlier, but I used a colon, and that's a range. But you cannot do a list of ports unless you start off with this match, this multi-port match. And then you can go in and do a comma-separated list. So 80, 443, whatever. What are those protocols? Those are your HTTP protocols. Basically your web protocols, right? 80 and 443. So HTTP and HTTPS. And dport actually supports typing that in. You can just type in HTTP, HTTPS. So that's fine as well. So over multiple ports, at the destination, these two ports. And then I want you to be matching a state. And here comes that state. So this says I want you to match on a state. And this is, well, here's the state I want you to match on. New and established. And then I want you to accept those. So if we went out and did this, this one. Change the default policy to drop. I don't want any packets coming in, but I still want the internet. Then this is the next logical rule. So what this says is, if the traffic that I'm going to is on 80 or 443, and then we establish a new or, if there is a new connection there, or if the packets are coming from an established connection already, allow it back in. So, yeah. If someone is sending me packets from 80 or 443 and I requested them, that's what this rule says. If I requested them, then the firewall will allow that in. The reason that it can be smart like that is because in the packet itself, there is a state. So the state is basically, it is not packet number 1. It's packet number 2, or packet number 3, or packet number 1544 in this particular TCP chain. So because it is not packet number 1, it'll let it in. Because there will already have had to have been a handshake gone on, that we already know that we're communicating with this entity out there on the internet or something like that. So this is the way. Change your default policy to drop, but then go in and allow internet. That's basically it. If you want to be as locked down as you possibly can, as far as people not being able to touch you, this is the rule that you want. When you are in Windows and you choose public, this is the rule that you get. I mean, obviously not in IP tables in the Windows firewall, but if it were running IP tables, this would be the only rule in the entire list. I don't want anything from anybody except for this, but the destination port would be any, actually. We'd have any destination port. This just allows internet. If you want full access to everything with this established type connection, then you can just put any in there or something. Leave that alone. All right. So here's the deal. IP tables is just like Cisco. What happens when you do not write mem or copy run start and then you reboot that thing? Poof. It all goes away. So if you get caught in that situation, hopefully you wrote down the commands that it took to build that firewall list up. Because if you didn't, yeah, it's all gone. It's all gone. So CentOS is actually the only operating system in this entire set of 3 that wants you to be dealing with IP tables. That's it. And even then, they're like, we have this thing called Firewall D that you can use. Use Firewall CMD and blah, 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 and deal with it that way. So, I mean, even the die-hard IP tables distribution still has ways for you to not have to directly deal with IP tables. IP tables is hard. I mean, I will be the first to admit IP tables is not the easiest thing in the world, but IP tables lives underneath every single application that you could ever want to run a GUI on. So if you understand how to at least read IP tables, then no matter what you run into, you'll know how to deal with your firewall. And that tends to be the approach that we've been taking with all the Linux stuff here anyway, right? All right, so if you want to actually save your IP tables rules, that's it in CentOS. If you do IP tables save, then that basically just says, here are all the rules. Here's everything that I've got in IP tables. If you want to save it, then you redirect that output to this file. So in CentOS, iptables-config is the file that contains the rules that you want to be applied on your firewall on boot. So if you need to save them, this is how you do it. This is the equivalent of the copy run start for your firewall, only for your firewall. Everything else is pretty much saved immediately. In Ubuntu, as I said, CentOS is the only one that wants you dealing with this. So in Ubuntu, you have to actually install additional packages to make this work. iptables save exists, but iptables persistent will create some rules for you. iptables and netfilter persistent will create rules for you. Otherwise, UFW just handles it. This is why you have to go the extra yard to make this work in Ubuntu, because UFW will handle it. There's a way for UFW to do just anything that you wanted it to do. You just have to learn the UFW syntax to deal with that. But if you just want to deal with iptables, and you absolutely can, you have to install these 2 packages and then run the same iptable save command, pop that over to rules v4 in etc iptables. OpenSUSE, good luck. is no. They want you using Firewall CMD or Firewall config. That is really just it. And there's a way to convert the SUSE Firewall 2 to the new Firewall D. I forget what the command is. You don't need to know that. But yeah, they just want you using Firewall CMD. Let me fix that. That's supposed to be that font. And that one is supposed to be that font. Yeah, just use one of those two options. That's just how you're going to be dealing with OpenSUSE. They want you using Firewall CMD or Firewall config in the GUI. Well, that's pretty much it. So as far as IP tables goes, that's all you really need to know. To be honest with you, be able to read them. That's the biggest thing. If you forget how to write them, that will be less damaging because you can always Google something like that. But being able to read them is a much more useful skill because you're going to run into a bunch of IP tables lists one day or another, and it would be advantageous to you if you can figure out what the heck any of that stuff means. But, obviously you can Google that stuff too. Not too big of a deal. But just know, if you have some basic IP tables chops, people will look at you like, ooh, you're a wizard. Seriously, IP tables is hard, and people understand this. So, yeah, don't feel too bad. If you're not getting it right off the bat, that is. IP tables is kind of like subnetting. Takes a while. Anyway, so if you want to do firewalling in the CentOS and OpenSUSE way, this is it. Firewall CMD. You're doing it from the command line. So Firewall CMD works like UFW in that it has a default zone. Typically, you're in the public zone right at the very beginning. So if you want to open up port 80 on the way in, this is how you do it. This is it. So Firewall CMD, I want to deal with the firewall. We're dealing with the public zone. That's the one that I'm in. You find out what zone you're in right here. And then if you're in the public zone or the work zone or whatever, that word goes right here. And then you just tell it the service name or port. And that's it. And now it's just open. So, yeah, makes it actually really easy to deal with. And you can see why people advocate for Firewall CMD rather than IP tables, because look at that. That's crazy simple. And, I mean, even when you get down to UFW, you realize you don't even need this. Like, wow, yeah. So, anyway, if you want to make it permanent, you got to add the -- permanent switch. This is how you basically create a rule and write mem at the same time, but just for that rule. And if you created a bunch of rules in Firewall CMD and you just want to save it all, this is the real equivalent to write mem, runtime to permanent. That will say all of the rules that I've created and that are in memory, I want them to be permanent, so run that command. That'll do it for you. Obviously, sudo in front of all that stuff. UFW, by default, write mem. But when you create a rule, it remembers it. It does. It's not a transient thing at all. If you want to remove it, UFW delete allow 80 TCP, something like that. But you could also do HTTP here. So UFW allow HTTP or 80/TCP, and you'll be good. So Firewall CMD still has a little bit of complexity to it, but even if you're doing very, very simple things, you have to know the zone and all that. UFW, yeah, the U in UFW stands for uncomplicated, and they try to live up to that name. And they do a pretty good job. I mean, as far as command line firewalling goes, it's about as easy as you're going to get. I don't think you can get easier than that, because you have to understand these concepts in the first place. I mean, you can't just stop thinking about how firewall works. You still have to have these things. But overall, yeah, that's pretty much it. Hey, firewall, allow port 80 over TCP. You can't get any more simple than that, because you have to have those bits in a firewall rule for the firewall to actually be able to act on anything. All right. So in this lab, all I'm having you guys do is write me out some rules. So you have to get them right as far as syntax goes, because you need to get IP tables to accept them. And really all I'm grading is this. So accept all HTTPS traffic. HTTPS traffic, there's a difference. Log all SSH traffic. Accept all SSH traffic. Deny all TCP traffic. And deny all TCP traffic. So That is IRC, by the way. No chatting. No chatting on my network. That's the idea. So anyway, you're just going to create 5 rules, put them in that order. Because remember, packets go from the top to the bottom. Once they match, they no longer continue on. So above everything, I want HTTPS traffic to be allowed. And then, like I said, do me an IP tables -L. That'll show me all of your tables. You can even do an L input. No, I'm sorry, you can't, because 2 of these are output. So, no, I'm sorry, 1 of these is output. Deny all traffic destined for port 194. So, no connecting to IRC servers on port 194, essentially. So, yeah, IP tables L will give me both your input and output chains, and I can check all these. So these 4 will be input, and this one will be output. Show me all those rules, and that'll do it. As far as the quiz goes, it's just random questions about IP tables. A couple of them are, write this particular IP tables rule, something like that. So it's more of the same, really. The lab and the quiz, yeah, they really do go hand in hand this week. So anyway, that's it. That's all I got for you guys. Any questions about any of that craziness? Okay. All right, yeah. Well, I'll kill the recording here.